example 3, I finally did put a rectangle on this one, sorry about that. A rectangular page is to contain 45 square inches of print. The margins on each side are 2 inches. Find the dimensions such that the least amount of paper is used. So if we draw a picture, maybe I should put my picture up top there. That way it's out of my way so I can do my work all together. Alright, so if we have our page is 45 square inches of print. The margins on each side are 2 inches. So right in here is my 45 square inches. And right here is 2 inches and 2 inches. That's all we know. So find the dimensions of our whole page. So I'm going to label this X and this Y. Alright, so what do we know? We know the area of our printable space. So step 1, we know that our area is 45 square inches. But that is our printable area, not the area of our paper, but our printable area. So, if that is our printable area, we need to write an equation for that. So, I labeled this X. So this length right here would be X minus 4. Questions on that? X minus 4. Alright. This would be Y. Here would be Y minus 4. You might ask, why am she subtracting 4? We have a margin of 2 and a margin of 2, so we have to take that away. So our printable area is equal to that. Questions? And I might have made this harder. So, step 2 is to say what they want to maximize or minimize. We want to minimize our paper area. So we're going to minimize the area of our paper, which the area of our paper would be the X times the Y. So step 3 is to solve this equation for one of our letters. So I'm going to divide by X minus 4. So I have Y minus 4 equals 45 divided by X minus 4. Then to solve for Y, I'm going to add 4 to the other side. So we got Y equals 45 over X minus 4 plus 4. So that one was a little more difficult to solve for Y. So step 4 is to put those two equations together. So we're going to put this in the place of Y. So we got our area equals X times 45 over X minus 4 plus 4. So we're going to distribute. So we get 45x over X minus 4 plus 4x. Yay, go us. So from there, we are going to find the derivative. So derivative of area equals, here you're going to have to do the quotient rule because X is in the numerator and X is in the denominator. So we're going to do our low times the derivative of the high, and you get 45x minus 180, and I'm not showing all my work because I don't have enough room. So low times the derivative of the high minus the high times the derivative of the low, which the derivative of the low is just what? Over the bottom squared. Then we have the derivative of 4x, so we have plus 4 out here in La La Land. Alright, so step 6 is to set that equal to 0. So if we set this big old fraction equal to 0, and I'm going to simplify my fraction and get negative 180 over x minus 4 quantity squared plus 4. From there, what we are going to do is solve for x. So I'm going to either move my fraction or move the 4. I'm going to move my fraction since it's negative. And I'm going to get 180 over x minus 4 quantity squared equals 4. From there, we're going to cross multiply so that we can get that denominator out of there, or x out of the denominator. So you get 180 equals 4 times this. So I'm going to go ahead and expand it out, use an area model, then distribute it to the 4. I'm not going to show the work, but you should get 4x squared negative 8x, so negative 32x. And then 16 times 4 is plus 64. From there, you're going to have to solve for x. So what you're going to have to do is, it's quadratic, so move the 180 to the other side. So we've got 4x squared minus 32x. 64 minus 180 is negative 116. So from there, you get to do an area model, or you get a factor. I forgot the x there. Or you can do quadratic formula. I'm going to do quadratic formula because I believe it's easier. So I'm going to do negative b. I'm not going to show this on the slide. Plus or minus the square root of b squared minus 4 times a times c. And I'm going to divide it by 2 times a. And I get 10.71. So then I'm going to do the negative, so I'm going to subtract my square root, and it would give me a negative answer of negative 2.7. So I'm not going to include that because a page can't be negatively. So x equals 10.71. Yay, go you. Now to find your y value, you're going to plug it in here. Step 3 has where y equals. So I'm going to go 45 divided by 10.71 minus 4. I'm going to add 4 to that answer, and I get 10.71 again. So y is 10.71. If you remember from the B's unit, a square gives you the most area. All right. This example is very similar to the last example, example 3. So a rectangular page is to contain 25 square inches of print. The margins at the top and the bottom are 1.5 inches, and the margin on the left or right are to be 0.5 inches, so it's a little bit different on your margins. Find the dimensions of the paper so that the least amount of paper is used. I'm not going to walk through all these steps. I'm just going to give you the answers. I believe that if you follow the last directive, you can try and come up with these answers. You should get x equals what do I have here? $3.89. So and y equals 11.66. So this one, for some reason, was not a perfect square. That one was a little different. Do you think maybe it has to do with the margins? Quite possibly. All right, the last example is dealing with a rectangle is bounded by the equation y equals negative x squared plus 2. So if we would graph that y equals negative x squared plus 2, it would be a parabola that is upside down. And they're saying that the rectangle is bounded inside there. So there's our rectangle, is what they're saying, this space in here. So they want to know what should the length and width be so that our area is a maximum. So the given information is y equals negative x squared plus 2. The good news is you won't have to solve in step 3. Step 2 is we want to maximize our area. So area equals, how do we find area of a rectangle? Well, length times width. So what is our width here? How far across is this? It is not x. from here to here is x, so all the way across is 2x. Our distance up is y. So this hard part is realizing this base is 2x across. Because you have to go x over, well, you got to go x back as well, so 2x altogether. All right, so step 3, it's already solved for us, so I'm going to skip step 3 and move to step 4. We're going to have our area equals 2x times negative x squared plus 2. Distribute negative 2x cubed plus 4x. So step 5 is to find the derivative for negative 6x squared plus 4. Step 6 is to set it equal to 0. So we have negative 6x squared plus 4. If we add 6x squared, divide by 6, and unsquare, you will get approximately, you can get the square root of 2/3, or 0.816. Now some of you are like, okay, this was x squared, so why didn't we do quadratic formula or factor? You could do either of those as well, but since it doesn't have a middle term, that b term, that's why you can just square root like we did. So watch that. Don't get in the habit of doing that. So that is x. We plug in here, right there, to get our y value. So negative 0.816 squared. Notice the negative is out here, so you just put in 0.86 squared, then take it times negative 1, then add 2, and you get y equals 1 1/3. Please come with questions for next time. This is one of the harder units because you are applying, and the key part is to be able to decipher what is going on in the problem. So come with questions for next time.